So afterwards, what I'd suggest, once you've got your notes on here, I would just tape this page into your book right on page 544 so that you see that you have those notes instead of the ones in the book. So there are a number of different questions that we could have. One would look like this, where they give you the equation and ask you to sketch the graph. So if that's the case, we're going to think about DAB-C. We're going to look at what it would look like. We graph it first without the transformation and then add the transformation afterwards. However, in this case, can you see that C is equal to 0? There's no shift left or right. So we won't even have to do that dotted line and then shift it afterwards because our starting point will start normally. Our center line is 13.7. Our amplitude is 4.5. And our B value, which is 0.16, tells us that our period is 2 pi divided by 0.16 pi, which, if you figure that out, it will be 12.5. So when we go to graph this, I'll start with my D value. It's 13.7. You don't have to make ticky marks all the way up. Just choose 13.7 for some value. That'll set some sort of scale up. That is your sinusoidal axis right there at y equals 13.7. Then if your amplitude is 4.5, now based on that, I would sort of estimate 4.5 would go down to there and up to there. Now 13.7 plus 4.5 will take us to 18.2, and 13.7 minus 4.5 will take us down to 9.2. So now we know what our maximum and our minimum are. Since our period is 12.5, we'll mark 12.5 on our x-axis and divide it into 4 equal sections. Start by dividing in half, divide it in half again, and then figure out the third one, 3.125 plus 6.25 will give us 9.375. The equation was a negative cos graph. Cos normally starts at a maximum, but because it's a negative cos, it's going to start at the minimum. Then we've got our 4 points back to the center, to the maximum, back to the center, down to the minimum. And there we have our sketch of our graph. In part B, it's saying that a big ship, bulk carrier, needs 14.5 meters of water to dock safely. So if we go back to here and think of our graph and put 14.5 on there, be a little bit here, somewhere around there, 14.5, draw waves. That's how deep the water needs to be. Can you see that it's only going to be safe in this section here? Because that's when the water is deeper. So we need to figure out when that happens. We need to figure out what time is it there and what time is it there in order to solve this. There's 2 ways of doing it. Both require your calculator. So I'm going to show you the easy way to solve it on your calculator first, using the power of your graphing calculator. And then if you didn't have a graphing calculator, you could still solve this, but the graphing calculator way is better. The first thing you're going to want to do is draw this out exactly as we see it. So we're going to go to our calculator, type in the equation, negative 4.5 cos 0.16 pi x plus 13.7. We're going to go to our window, and for our graph here, along my x-axis, I go up to 12.5. That means your batteries are low and dead, almost so. Okay, well, we'll check it out. Check my equation if I typed it in right? Sure. Negative 4.5 cos 0.16 pi plus 13.7. And that'll be the same equation that we have on our sheet, right? So now we have to set up our window. Go to our window. I'm going to go up to 13 because that'll show one period, because our period went up to 12.5. I'm going to make my x scale 3.125 because that's where I made the first ticking mark, just so I can see those ones exactly as we saw. For my y, I'm going to go from -1. We go up to 18.2, so I'll go just a little bit more, up to 20. My y scale, I'll keep it at 5. And there's the graph, almost identical to what we graphed to begin with.
Do you have the coordinates again?
To the window?
Yeah. No, with the y values.
Oh, the y values, you can also just find that from your paper, right? Because the equation's right there.
Okay.
So what we're also going to do in our y values is we're going to show that level of water that it has to be at. Remember that it was only safe it was 14.5 or deeper. So I'm going to type in y equals 14.5 because that'll draw a horizontal line right at 14.5. My graphing calculator water is red. So I went to y equals, and in y2 I typed in 14.5. Now your calculator is very powerful. As soon as it has two equations like this, it can figure out exactly where those two are intersecting. All the stuff that you calculate with your calculator, above the trace button you see the word calculate. If you go to that menu, it lets you find a bunch of different things. What we're going to want to find here is the fifth one, intersect. And if you push enter, it jumps from one curve to the other. Push enter again. Then it asks you to guess. Push enter again. And it will always find the closest one. Second trace.
Today at the 1 o'clock shuttle. If you could please meet in the cafeteria at the noon hour at 12 o'clock to see Ms. Jensen. Thank you.
So we figured out that that first one was 3.48. If you want to go through those steps again of how to find it, yeah, go ahead. Only displaying one graph. When you write them both in, are both equal signs highlighted? And if it doesn't let you highlight the second one, I can fix that. So let's find the other intersection point. Second, calculate 5, intersection. It will always find the one it's closest to. So if I move my cursor to the right, until I'm closer to the other one. That should be close enough. Enter, enter, enter. It'll now find the other one, which happens at 9.02. So now we've found them both. The question asks for how many hours per cycle can it safely dock if we take the 9.02 and minus the 3.48, we will get 6 point, no, 5 point, I'll figure it out on my calculator. What do we get? 9.02 minus 3.48, 5.54 hours. So that's using your graphing calculator and all of its powers. Now I'm also going to show you, if you had this same question and you didn't have a graphing calculator, you could use all of our reference angle and stuff like that to solve it as well. In university it would. Not non-calculator, but in university you might have a non-graphing calculator class. So don't write this down. It'll be on the video afterwards if you want to look at it. So what you would do is you would start by saying, since we know the depth has to be 14.5 meters, we could replace that for y. And when I plug that in, I just need to solve this equation for t. Now this is a sine and a cos equation. Just like you've done in the past, you're going to try and get cos all by itself. So if you subtracted 13.7 on both sides, then you get 0.8. And then if you divided both sides by negative 4.5, you would get cos all by itself. Now this is harder than our normal cos questions, because if you had just this, it would seem easier. First of all, you'd see the answer is negative. That would make you think cos is negative in quadrants 2 and quadrants 3. You'd find your reference angle, and then you'd solve for it. But right now, we've got a whole bunch of stuff in there, which makes it more complicated. So what we do is we make it simpler by doing exactly that. We just temporarily make the whole inside equal to theta, because then our question looks like the easier question. You know it's in quadrant 2 and in quadrant 3. So you do cos inverse and find your reference angle. When you do cos inverse, it's always the positive values, because reference angles are always positive. And in radians, we find it has a reference angle of 1.392. So you could find out what that would be in quadrant 2 by doing pi minus, and in quadrant 3 by doing pi plus. So now we figured out what theta is, but remember, what did we do with theta? We made theta equal to this. So now that we figured out what theta is, we could substitute back. And instead of writing theta equals, we could write 0.16 pi t equals, divide, and we get the same answer of 3.48 for the first one. Similarly, you substitute back in the other one, and you get 9.02. And you still get 5.54 hours. So this will be online if you wanted to look at the algebraic stuff again. Yeah, I'll put it on tonight.